In this video, we will turn to other tools that we can use to work with text and create some interesting outputs and I want to show you some ways that textual data is analyzed and can be used. Unfortunately, because there are so many methods for working with text and so many different types of outputs or things we might be interested in, that I can't go through and detail all of these things here. So I'm going to introduce you to some of the most widely used and most sort of interesting to tools and outputs. Then after I introduce those, in this document I have other links to things. If you're interested in learning more about how to work with text, you can go and look up information in these links. We have a bunch of packages. This is just a great representation of how many approaches there are to working with text and how many tools. So we're going to read in all of these packages. Then I'm not going to go through what each of these packages do, but you could look them up and learn about them. So the first thing we need to do is collect a corpus. So that is like the combination of documents that we're going to be looking at. So I put a folder of documents in this week's material, and for the homework there will be a folder of documents. So this list files just creates a list of all the files that are within a folder. So here we have this folder, I'm calling it conference calls, and you put the file path here, and full name says get the full file path to that file. And so when I run this, you'll see that it outputs the files that I'm using to analyze in this video. So I've got 1, 2, 3, 4, 5, 6 documents. These are all conference calls from different companies, and we're going to analyze them together as a group of documents rather than, like in the last video, pulling things out of a single document. So for some of these tools, we have to create the corpus so that they can work on all of the documents together. So one of these packages, they have this function map into a data frame the files that we have. So this is the file list that we created up here. That is the list of all of the documents. Then it says turn it into a data frame, and how we're going to do that is read the file, which we saw last time. We're going to put that into text, and we're going to put that in a column called txt. This part is just part of the syntax of how to do this. So we're going to read this in, map everything from these files into a data frame that has a text that is this here. Then we're also going to create a new column. This is call file. This is another function from that same package that says take the name of whatever this document is. So it's going to create a column that names each of the documents. And then the final piece we're going to do is unnest tokens, and we're going to do that creating by word, creating a list of words, and using this txt column. So that's a lot to sort of work through. The nice part is that these are fairly general approaches so that you don't have to mess around with it too much. And this will be the same thing you'll be doing in the homework. If you're interested in other ways, of course, you can go look those up as well. So we run this. What that is going to do is create now a data frame that puts all of the documents into that data frame. We can look at it and see this is the call file is the document that it's coming from. So notice all of these first ones are from the same document, and then it splits up what it thinks are words in that document. So you could kind of walk your way down reading the document through this way. Just like we saw before, at the beginning of some of these, it lists all of the participants in the conference call, and it walks through all of these words in the document. Well, one of the first things we do is, in working with text, and especially when we're creating some of these models, is to find a way to summarize everything that is in the text. And one of those ways is to summarize by word. So for example, the word company, how many times does that show up in the document? Or the word innovation, how many times does that show up in the document? This is similar to the dictionary methods that we used in the last video that counts positive or negative words, but here we're just counting the individual words. So let's walk through what we're doing there. We're taking the corpus. This is what we have up here that we created. This is the data frame of all of the documents together. We're going to group by word, so that means each word by itself is going to have the next steps done to it. The summarize that we're going to do is count how many words there are for each word. And then this is going to do the whole set of documents. Of course, we could break that up by document or something like that. And we're going to count just by summarizing in, so how many times does it show up in that document. Then we can, here I'm just sorting, descending to get the highest word count up at the top so we can look at it. And when we look here, there are 4,438 items that it thinks are words. And the top ones are the, to, and, of, right? Words that you would expect to show up over and over in any document. So these ones don't really tell us a whole lot. Maybe when we get down further, we start to get things that are meaningful and specific to these documents. So for example, analyst would be something that we see more often in a conference call than in other settings. But sometimes if we want to be able to look at in detail what the document is saying, we want to get rid of words like the and to and those are called stop words because they're not going to be very different between one document and another, and so it may not inform us much about the document. So one of the packages again has this thing that says get stop words. It's just a function from that package, and notice it has some of these words that it says let's get rid of these words. These are words that are not meaningful across documents. So we can do this merging. So I introduced this in class. If we take the document set that we already have, and remember this is by word, we can join on this list of words. This get stop words will get the list of words and match anything from this data set that or document set that is not in this list of stop words. So once we do that, you can see it reduced the number of words over here, and then we can do the same thing to look at the word counts across all of the documents. So before we do this, notice we had 4,438 words. Now we have 4,289 words, so it decreased. And let's see what we have. So at the top we have think, just, year. So some of them aren't terribly insightful, but more so than sort of these original words that we call stop words. Well, some of these in here have numbers in them, so maybe we want to get rid of those. And why does it have numbers? It's because it identifies words just by separations between words. So we see here we have a bunch of numbers. We could want to call those something meaningful, but most often numbers are things that we need to interpret not as text but as actual numbers. So what if we want to get rid of those? Well, we could use our tools from last time. So string detect in the word column a digit. So if you find that not equals true, meaning if it is not true, then keep it, right? So we're filtering to keep all those that don't have digits. So temp, we have 25851. Run it again, 24911. So we knocked out some of those ones that have numbers in them. One of the popular tools that we see that helps us visualize some of what's going on in a document are called word clouds. So this is from the word cloud package. So we can create a list of all of the words and how many words there are. So if we do that, here, this count word, it's a little more complicated than just a simple thing, but it's very similar to what we're doing up here, where we do group by word and then summarize by word count, or summarize the word count, right, the number for each word group. That's essentially what's happening here with this count function. So it's a sort of a shortcut to doing both of these. I just thought I would introduce it. You don't need to use that. You could use what we have done before, which is the group by and summarize. And then this next one is to do this with. We haven't used the with syntax, so it's just something you can sort of plug in here. So with, we are working with this word cloud. That's part of the package. And then we have to tell it the words. So I've counted the words. We have, this is what we're going to use. And then in is the number that is the count, and that comes out of doing this count word function. Up here, we called it word count, so we could have word and then word count here. And then on the plot, we're just going to use 100 words maximum. So when that comes out, it gives us a word cloud. So if we get the right set of documents or the right set of words, sometimes this can be really insightful. Here, not too insightful. I mean, it gives us an idea of some of the things that are most commonly said. Yes, or continue, or next. So those are a little bit like stop words as well. Maybe we might want to get something else in there. Some other nonsense things come up, JPY. That's not telling us a lot about what they're talking about. Other ones that do make more sense, they talk a lot about costs or what companies expect, things like that, right? Customers. So it's a nice tool. Sometimes it gives you interesting insights. I think it's worth understanding how to do those tools. Of course, if we change the underlying set of words, we can get more or less interesting word clouds out of that. So let's introduce a couple of other things. Sometimes we still have to clean up words. So some of these words have punctuations in them. And again, that's just because of these tools can't cleanly separate all of the words, right? It gets things that look like words, or it gets words that have punctuation in them, and maybe that's not the same across all documents or all instances where that word is used. So often we want to clean some stuff out. So here, right, we're working with the word column, calling it the word column, and string replace all means find a pattern and replace that pattern with something. It's from the stringer package, very similar to what we did before. And the thing we're trying to find is anything that is punctuation, and we're going to replace it with nothing. So, right, so empty quotations. Then once we do that, there's another tool that is WordStem, which says it's going to try to use an algorithm to reduce words to just the stem of their words. So instead of expecting, it's going to try and reduce it down to something like expect. This isn't a foolproof method either, but it gives us sort of a simple way to do some stemming here. So once we look at this, you'll see it has simplified some of the words. So we look in here and we see some of these it has cut down. It doesn't always do a perfect job, but it gets some of what we're hoping for. Well, the benefit of doing word stemming is sometimes that'll allow us to aggregate words a little better. Not always, but sometimes. So let's go and pull up that. Same thing we did before. Let's look at the list. So the highest one is think, of course. That was the same as it was before. But do we see some that show up maybe a little more frequently now? Continue without an E or ing. It has reduced the number of words a little bit more and possibly given us some cleaner data to work with. So then once we have all of this prepared, and the reason why we go through all of this preparation is because sometimes we want to get something out of the text, right? So we prepare it all to get these list of words that maybe we can learn something about the document. Well, I'm going to introduce 3 techniques that people use to learn something about a set of documents. The first one is how similar are the documents, and it uses a function. It's called cosine similarity, but it just says more or less how do words in one document, are they similar to the words in another document? And that's basically it. Okay, this count function we already talked about. I'm going to go back to this group by and summarize here because this is what we worked with mostly. Take our already cleaned words. We're going to create a similarity. So this is, I'm calling this the cosine similarity output. We're going to do it for each call by itself, and we're going to use the word column. So again, summarize to get in as the number of words. Ungroups, because now we're not working by words anymore. Then the function is pairwise similarity, and we need to tell it what is the document identifier here, what is the word we're using. This is the column for word, this is the column for how many there are, and then once we do this pairwise similarity, it's going to create a column called similarity, and I'm going to sort it to see which documents are most similar. So in here, notice it does each document with every other document. So the two most similar are SVB and Amazon. In their conference calls, they're the most similar. This is the highest similarity number. Notice the next one is exactly the same. That's because now it just did the reverse order, Amazon to SVB instead of SVB to Amazon. Then the least similar, if we go to the bottom, are HMC and Plus. I can't remember what company these are, but these are the least similar. We don't need to know what 0.29 means, but we know 0.29 is much smaller than 0.55. So these are the least similar. These are the most similar. So you might use this if you're trying to identify where documents have changed. So someone creates a they have their annual report, and you want to see if it's very similar or if it's changed a lot. Or if you've got two individuals posting on social media, and which are they similar or are they not similar? Different uses for using this sort of tool. Another thing that sometimes people are interested in is trying to get a summary idea of what the topics of the document are. Again, it uses a sort of interesting algorithm. You can read through these background links as well. And it's going to try and say, using these algorithms, can we identify words that give us an idea of what the topics are in one document versus another document. So we have to create what is called a document term matrix. So up here so far we have a setup that is the tidy text setup. So there are some links on that. So notice here we've got the document, then we have individual words. Well, in a document term matrix, it has columns and rows, a huge matrix of these, so we can look at that. So it creates this document term matrix, and it's even hard to tell what everything is. But it goes through and has, for each document, so this would be a row, then for each document, each column is the word, or here the word stem. And then within the matrix are these things, the number of times, right here, the number of times that those words show up in that document. So once we output that document term matrix, it's not in a great, easy to use format, but we've got this big matrix of all of these words in these documents. Then we can use some of the tools from these packages to pull out the terms. And what it's trying to do is sort of collapse into the most important words. So here we're going to use this function here. It's going to pull out from the document term matrix certain topics, and here we're going to tell it to pull out 5. We have to define how many topics to pull out. So it's going to pull out 5 topics. Takes a little bit to run the algorithm. Then we're going to check what those topics are. So we can do the topics from the 5 topics, from this object that came out of this. And we're going to make it into a matrix so we can look at it. And we look here and see the first call, the topic that it's determined is number 4. Second, it's number 2. These ones down here have done are the third topic. So what does that tell us? Where does it come from? Well, we can now get the terms instead of the topic numbers here. And if we open the terms, we see the first topic that it identifies are, oh, sorry, I forgot to mention. So I'm just going to get the 10 most common words, the 10 most important words in determining these topics. You could change this to a smaller or larger number. So here are the 10 most common words that define these topics. The first one is foreign, year, language. Second, custom, year, cost. So this one may be talking more about cost. This one, think, go, just, see. So maybe this is, thinking about what's happening for the company, right? So we've got each of these things. The fifth one is all Elon Musk. We don't have, it doesn't tell you this is the topic, but it gives you words that it thinks are most related to that topic. So if we go back to what these topics are, it says, for example, the Tesla conference call, it's topic number 5. Well, that's the one with Elon in it. Amazon, topic number 2, which is custom, year, cost, question, see, last. Oh, well, then Amazon shows up too, because it's all of their list of words, right? But even though this says, let's use one that has multiple, number 3, plus an SVB. So they both talk about analysts and chief, officers, quarter. Of course, all of them will use that. Thank you, sort of things. So it gives us a way to sort of narrow down what the types of things they're talking about in each of these calls and how each topic can be different across the calls. So one more tool then. The last tool we're going to do is just like what we did before, is positive and negative words, but now we're going to apply it to the entire document, or sets of documents, the entire corpus. So we're going to get the sentiment dictionary. We saw this before. Get sentiments. Well, there are different ones. I think we used a similar one last time. So we're going to get the sentiments. Gives us a dictionary over here. All of these words we saw before. Now only keep words that are positive or negative. This is going to be our word list for each of those. Now we're going to take our set of documents here, inner join, meaning only keep those that are in both data frames, so only words that are in this and in the positive list. Then once we've joined them, group by the document, and then count how many, so summarize in how many of those words are there in this document that only has the positive words because we did this joining ahead of time. So if we look at sentiment 1, now this gives us a count of each of the documents, how many positive words there were in each of the documents. We can do the same thing with the negative words. Then if we want to get the two together, right, so the thing that is in the sentiment 1 and sentiment 2 files, these are the number of positive words, and then we have the file that it came from. That's the same thing in the sentiment 2, the file that it came from in negative words, so it's going to merge based on this file that it came from. And inner join only keeps if it's in both documents. So we create this new data frame, and now we have the positive and negative words from each document. And we can do what we did before, create a new column that measures sentiment, and then let's sort it by the most negative. And we see the most positive, I said the most negative. So the most positive is the Tesla call. The least positive is this company down here. Amazon is almost as positive as Tesla. Plus is slightly less, and then these others become negative. All right, so it's a lot of sort of details in the different syntaxes to use for each of these approaches. But let's go back and sort of summarize some of this. So we have lots of tools we can use. We need to get the list of files into a corpus that we can work with. We can then look at the documents by the words that are in the documents. We can clean up the words that are in the documents various ways, right? Getting rid of stop words, getting rid of, cleaning, like getting rid of numbers and punctuation. We can stem the words, and then we have a few tools. These aren't the only tools that are out there, but they're some of the more popular tools right now. We can look at how similar documents are. We can try and get out topics that are in the documents, and we can try and summarize words here, sentiment, in the documents as well. So lots of tools, lots of possibilities. The homework will go very closely with this code in the new set of documents. What I want you to do is experiment seeing how the code works and trying to learn some of the syntax and get a sense of sort of what's available for you to work with these sorts of text and combinations of texts.